What if I told you that an object from another star system has entered our solar system, and within hours, the internet decided it was alien technology? But here's the real mystery. The object isn't the strangest thing. The strangest thing is how easily science itself can be hijacked in the age of artificial intelligence. Tonight, let's separate cosmic fact from digital fiction and uncover what 3i Atlas really tells us about the universe and about ourselves. Imagine for a moment that you are standing on a quiet beach at night. The waves roll in, the stars hang motionless above you, everything feels familiar. Then suddenly, without warning, a grain of sand lands at your feet that did not come from Earth, did not come from our sun, and did not come from anything that has ever orbited our planet before. That, in essence, is what 3i Atlas represents. It is not just another rock in space. It is a messenger, a relic, a fossil from another stellar system that has wandered the galaxy for billions of years before briefly crossing our path. Only 3 such objects have ever been confirmed in human history, and that alone should make us pause. The universe is vast beyond comprehension, yet it has chosen this precise moment in our technological development to whisper a clue about its deeper workings. 3i Atlas is an interstellar object, meaning it was born around another star entirely, long before our sun ignited, long before the Earth cooled enough to form oceans. This object was already drifting through the cold vacuum between stars. It carries within it the chemical fingerprints of a different solar nursery, shaped by alien radiation, alien gravity, and alien cosmic storms. When astronomers detected it, they did not see engines, antennas, or signals. They saw something far more subtle and far more powerful: motion. Its trajectory could not be explained by any orbit bound to our sun. Its speed was too high, its path too straight. Physics itself told us that this visitor did not belong to us. This is how science works at its best. We do not begin with speculation, we begin with equations. Gravity leaves signatures. Energy leaves trails. When something violates the expectations of a closed system, we know it came from outside. That is not science fiction. That is Newton, Einstein, and Kepler speaking across centuries. 3i Atlas obeys these laws with remarkable consistency. Its behavior, once analyzed carefully, fits beautifully within what we expect from a natural interstellar body, a comet-like object strip of familiar features by eons of cosmic travel. Its surface altered by radiation and extreme cold, its structure hardened by time. Yet, the moment this information reached the public, something fascinating happened. The object became alien in a very different sense. Social media exploded with speculation, dramatic music, and claims that went far beyond the data. This reaction tells us something profound, not about the object, but about ourselves. We live in an era where discovery travels faster than understanding. When people hear interstellar, they instinctively leap to intention, design, and intelligence. But the universe does not need intention to create wonders. Gravity alone can sculpt structures more elegant than any engineer could design. To a physicist, the true miracle is not that such objects exist, but that we can detect them at all. Consider the precision required. Tiny variations in light, minute shifts in position against the background stars, calculations performed with extraordinary accuracy. All of this just to notice a faint traveler passing silently through our cosmic neighborhood. This is not evidence of extraterrestrial technology, it is evidence of human ingenuity. We are finally developing the tools to read the universe's diary, page by page. Now comes the deeper question: why do interstellar objects feel so unsettling, so irresistibly mysterious? The answer lies in psychology as much as physics. For all of human history, we believed our solar system was a closed neighborhood. The sun, the planets, the comets, everything had a local address. Interstellar objects shatter that comforting illusion. They remind us that space is not static, it is dynamic, chaotic, and interconnected. Material from distant stars routinely crosses the galaxy, exchanging information, chemistry, and history. In a very real sense, the universe is not made of isolated islands, but of constant travelers. When something unfamiliar appears, our brains are wired to search for agency. This instinct kept our ancestors alive. A rustling in the bushes might have been the wind, or it might have been a predator. Today, that same instinct pushes us to see technology where there's only physics. When 3i Atlas doesn't behave like a typical comet we learned about in textbooks, the mind fills in the gaps with imagination. But nature has always been stranger than our expectations. Neutron stars spin hundreds of times per second. Black holes bend time itself. Quantum particles exist in multiple states simultaneously. None of these phenomena were designed. They emerged inevitably from the laws of physics. Interstellar objects are shaped by environments far harsher than anything in our solar system. They endure supernova shock waves, intense radiation fields, and gravitational encounters with rogue stars. By the time they reach us, they may no longer resemble the comets we know. Their surfaces can be baked, cracked, and chemically altered beyond recognition. When we expect familiarity and encounter difference, we label it alien. But alien does not mean artificial. It simply means foreign to our experience. This distinction is crucial. Science advances not by sensationalism, but by humility. The universe owes us no obligation to look familiar. In fact, the more we explore, the more we should expect surprise. The danger arises when surprise turns into certainty without evidence. In physics, we are trained to ask a simple question: what is the simplest explanation that fits the data? So far, every observation of 3I, Atlas aligns with natural process, we already understand, extended into extreme regimes of time and space. And yet there is something profoundly poetic about these objects. They are storytellers. They carry information from places we may never visit. By studying them, we learn not only about distant star systems, but about our own origins. The atoms in your body were once forged in ancient stars. Interstellar objects are reminders that cosmic exchange is not an abstract concept, it is a physical reality. The universe recycles itself endlessly, and we are part of that cycle. The real wonder, then, is not whether 3I Atlas is artificial. The real wonder is that the universe is generous enough to send us clues at all. Each interstellar visitor expands our understanding of planetary formation, of chemical evolution, of how common or rare certain processes might be across the galaxy. These are the questions that truly matter because they move us closer to answering one of humanity's oldest mysteries: how did we come to be? Curiosity is the engine of science, but discipline is its steering wheel. Without discipline, curiosity spins into fantasy. With discipline, it becomes knowledge. Interstellar objects sit precisely at this intersection. They ignite our imagination while demanding our restraint. They invite us to dream, but insist that we measure, calculate, and verify. In the end, the universe is not trying to fool us, impress us, or contact us. It is simply being itself, following laws written into the fabric of space and time. Our task is not to project our hopes and fears onto it, but to listen carefully. When we do, we discover that reality, grounded in physics, is far more astonishing than any deepfake, any rumor, or any invented narrative could ever be. We now live at a strange crossroads in human history, where our ability to observe the universe has become extraordinarily powerful, yet our ability to distort reality has grown just as fast. In the past, scientific authority came from peer-reviewed journals, chalkboards filled with equations, and decades of careful verification. Today, authority can be manufactured in minutes. A face, a voice, a familiar cadence, all can be synthesized. This is where the danger begins, not in space, but here on Earth. Artificial intelligence has reached a point where it can convincingly imitate scientists, create statements that were never spoken, and spread them across the globe before truth even has a chance to put on its shoes. When an interstellar object like 3I Atlas appears, it becomes the perfect catalyst for confusion because it sits at the intersection of real science and human imagination. What makes this moment particularly delicate is that science depends on trust. The public cannot personally verify orbital mechanics, spectroscopic data, or radiation models. They rely on experts to interpret those signals. When AI deepfakes insert false claims into the mouths of scientists, they do not merely spread misinformation, they corrode the very foundation of scientific communication. Suddenly, the question is no longer what does the data say, but did this person actually say this? That shift is catastrophic. It moves us away from evidence and towards spectacle. In such an environment, even legitimate discoveries risk being dismissed as hoaxes, while false narratives gain traction simply because they are dramatic. Physics, however, is wonderfully indifferent to drama. The universe does not care about viral videos or trending hashtags. It speaks in the language of mathematics, and that language is brutally honest. When analyzing an object like 3I Atlas, physicists do not begin by asking what would excite the public. They ask how fast it is moving, how its trajectory curves under gravity, how its brightness changes over time, and what its spectrum reveals about its composition. These measurements are not opinions, they are fingerprints. And just as no two human fingerprints are identical artificial objects, and natural objects leave radically different physical signatures. This is where the laws of physics become our most reliable defense against deception. Artificial technology, no matter how advanced, must obey conservation laws. It must dissipate heat. It must interact with radiation in predictable ways. It must exhibit signs of control or propulsion if it is maneuvering. Natural objects, on the other hand, are slaves to gravity, momentum, and thermodynamics. So far, 3I, Atlas, shows no deviation from what nature alone can produce. Its motion follows a smooth, gravity-dominated path. Its emissions align with non-engine processes. There are no unexplained accelerations, no energy outputs that violate, no limits. No signatures that demand intelligence as an explanation. This distinction is crucial because the phrase "we don't fully understand it" is often misinterpreted. In science, not fully understanding something does not mean anything is possible. It means we are refining models within known boundaries. When astronomers say an object behaves unusually, they mean relative to previous examples, not relative to physics itself. The universe is vast enough to produce rare phenomena without invoking design. In fact, rarity is expected. Given billions of stars and countless planetary systems, extreme outliers are inevitable. The mistake is assuming that unfamiliar equals artificial. Deepfake science thrives on exploiting this misunderstanding. It takes legitimate uncertainty and inflates it into sensational conclusions. A sentence removed from context, a speculative remark exaggerated into a declaration. A cautious "we are studying" transformed into "we have confirmed." This is not how science advances. Science advances through skepticism, repetition, and error correction. AI, when misused, short-circuits that process by presenting polished falsehoods that feel authoritative. The danger is not that people will believe in aliens. The danger is that people will stop believing in the scientific method itself. Yet there is an irony here. The same physics that allows us to debunk false claims is the physics that makes the universe so astonishing. When we analyze interstellar objects, we are engaging in one of humanity's greatest intellectual achievements, reading the history of the cosmos without ever leaving Earth. By decoding how light interacts with matter, we can determine an object's composition from millions of kilometers away. By tracking its motion, we can reconstruct its past journey through the galaxy. This is not speculation. This is forensic science on a cosmic scale. The laws of physics act like a cosmic constitution. They apply everywhere without exception. Any claim that violates them must meet an extraordinary burden of proof. Faster than light travel, reactionless propulsion, energy creation from nothing. These ideas are not rejected because they are boring, but because they contradict everything we have ever measured. Could new physics exist? Absolutely. But new physics does not emerge from blurry videos and anonymous claims. It emerges from precise experiments, reproducible results, and mathematical consistency. There is also a deeper philosophical lesson here. Humans are storytelling creatures. We crave narratives with intention and meaning. A random rock drifting through space feels unsatisfying compared to a probe sent by an advanced civilization. But the universe is under no obligation to satisfy our narrative preferences. In fact, some of the most profound truths in physics are deeply counterintuitive. Time slows near massive objects. Space itself expands. Particles influence each other instantaneously across vast distances. None of these ideas are comforting or intuitive, yet they are true because nature says so. The challenge of our era is learning to coexist with both awe and discipline. Awe drives us to look up at the stars and ask whether we are alone. Discipline reminds us that answers must be earned, not imagined. When AI deepfakes blur the line between reality and fiction, the responsibility of scientists and communicators becomes even greater. We must not only explain the universe, but also explain how we know what we know. Transparency, methodology, and humility become essential tools. Physics does not eliminate wonder, it deepens it. Knowing that 3I, Atlas, is a natural interstellar object does not make it less fascinating. On the contrary, it makes it more remarkable. It means that star systems are not isolated. It means that material from distant suns routinely wanders through the galaxy. It means that the building blocks of planets, and perhaps life are exchanged on cosmic timescales. That realization is far more transformative than any fabricated claim could ever be. In the end, the real confrontation is not between humans and extraterrestrials, but between reason and illusion. The universe invites us to explore, to question, and to imagine, but it also demands that we respect its rules. AI can generate convincing images and voices, but it cannot rewrite gravity, thermodynamics, or quantum mechanics. Those laws remain unyielding, silent, and reliable. If we anchor ourselves to them, we can navigate even the most sensational claims without losing our way, and continue the great human project of understanding the cosmos as it truly is, not as we wish it to be. One of the most persistent misconceptions about science is the idea that scientists begin by searching for extraordinary explanations. In reality, the opposite is true. Science is, by nature, conservative. It resists dramatic conclusions not because they are uncomfortable, but because history has taught us how easily the human mind can be misled. When confronted with something unfamiliar, like an interstellar object passing through our solar system, the scientific instinct is not to ask, could this be aliens? But rather, what do we know for certain? And what can be explained using the simplest, most tested principles we have? This approach is not dull, it is powerful. It is the reason airplanes fly, satellites function, and medical imaging works. It is also the reason science progresses without collapsing under the weight of speculation. Extraordinary claims sit at the far end of a long investigative road. To reach them, one must first exhaust every natural explanation. This is not a philosophical preference, it is a practical necessity. The universe is governed by consistent laws, and those laws have proven astonishingly reliable across vast scales of space and time. When an object like 3I, Atlas, enters the scene, it must first be evaluated through the lens of gravity, momentum, chemistry, and radiation. If these frameworks fail completely, only then does science begin to consider radical alternatives. Skipping these steps is not bold thinking, it is intellectual negligence. The phrase extraordinary claims require extraordinary evidence is often quoted but rarely understood. Extraordinary evidence does not mean emotional conviction or widespread belief. It means data so robust that it forces the rewriting of textbooks. It means independent confirmation, reproducibility, and predictive power. A claim of artificial origin would require clear signs of engineering, controlled motion, non-natural energy emissions, or communication signals that cannot arise from known physical processes. So far, none of these have appeared. The absence of such evidence is not a failure of imagination, it is a triumph of rigor. Skepticism, in this context, is frequently misunderstood as denial or closed-mindedness. In truth, skepticism is the heartbeat of science. It is what prevents us from mistaking noise for signal, coincidence for causation, and novelty for truth. Every major breakthrough in physics survived intense skepticism before being accepted. Relativity, quantum mechanics, and the expansion of the universe were all controversial in their time. They prevailed not because they were exciting, but because they worked. They explained observations more accurately than anything before them. That is the standard any new claim must meet. While the public conversation often fixates on whether interstellar objects are artificial, scientists are asking a far more interesting question. What do these objects reveal about the formation and evolution of planetary systems across the galaxy? Each interstellar visitor is a time capsule. It contains chemical clues about the environment in which it formed, the types of materials present, and the physical processes that shaped it. By analyzing these clues, we gain insight into how common certain elements are, how planets assemble, and how matter migrates between stars. This knowledge does not make headlines, but it quietly reshapes our understanding of the cosmos. Interstellar objects also challenge our assumptions about isolation. For centuries, we imagined solar systems as largely self-contained. Yet these travelers demonstrate that material routinely escapes from one system and enters another. Collisions, gravitational interactions, and stellar evolution can eject debris into interstellar space, where it wanders until captured or observed. This means that the galaxy is not a collection of sealed boxes, but a dynamic network of exchange. In a poetic sense, we are studying pieces of distant worlds without ever leaving home. This perspective subtly alters the question of life in the universe. Instead of asking only whether intelligent civilizations visit us, we begin to ask how chemistry itself spreads across the galaxy. Organic molecules, water-bearing minerals, and complex compounds may hitch rides on interstellar objects, seeding young systems with the ingredients for life. This is not speculation in the sensational sense. It is grounded in chemistry and astrophysics. The building blocks of life are remarkably resilient. They can survive extreme cold, radiation, and time. Interstellar exchange may be one of the quiet mechanisms by which the galaxy becomes biologically fertile. When viewed this way, the obsession with artificial origin begins to feel misplaced. The real story is not about visitors watching us, but about a universe that constantly recycles and redistributes its raw materials. We are not isolated observers in a cosmic void. We are participants in an ongoing galactic process. Every atom in your body has a history that predates the Earth. Interstellar objects simply make that history visible in motion. There is also a sobering lesson in humility. Human technology, impressive as it is, remains constrained by energy, materials, and time. Interstellar travel is not impossible, but it is extraordinarily difficult. Even a civilization far more advanced than ours would face immense challenges in sending probes across vast distances. This does not rule out extraterrestrial intelligence, but it places it within a realistic physical framework. Science does not dismiss possibilities. It assigns them probabilities based on evidence. By focusing on what interstellar objects truly teach us, science avoids the trap of anthropocentrism. The universe is not arranged around our expectations or narratives. It is governed by impersonal laws that operate with stunning consistency. Understanding those laws does not diminish wonder, it amplifies it. Knowing that a small object drifting past Earth carries within it the story of another star system is far more profound than any unfounded claim of surveillance or contact. Ultimately, the strength of science lies in its patience. It does not rush to conclusions. It allows mystery to exist without filling it prematurely with fiction. In an age where attention is currency and speculation spreads faster than understanding, this patience is revolutionary. It reminds us that truth is not determined by volume or virality, but by evidence and coherence. By embracing skepticism and focusing on the deeper questions interstellar objects raise, we move closer to a genuine understanding of our place in the cosmos, guided not by fear or fantasy, but by curiosity, disciplined by reason. When we strip away the noise, the speculation, and the sensationalism, what remains is something far more valuable: information. Interstellar objects are not messages sent to us, but messages carried by nature itself. They are fragments of other star systems, shaped long before our planet existed, carrying within them clues about how worlds are born and how they evolve. Each one is a chapter torn from a book written billions of years ago, drifting through space until by chance we are able to read a few lines. This is the true significance of objects like 3I Atlas. They allow us to test our theories of planetary formation not in simulations or laboratories, but against reality itself. By studying their composition, we learn what kinds of materials are common beyond our solar system. Are water-rich minerals rare or abundant? Do complex organic compounds form easily or only under special conditions? These are not abstract questions. They cut directly to the mystery of life's origins. If the ingredients for life are widespread and resilient, then the emergence of biology may be a cosmic tendency rather than a cosmic accident. Interstellar objects give us physical evidence to examine, not guesses. Spectroscopy reveals the elements they contain. Their structure tells us about the temperatures and pressures they endured. Their trajectories reveal the gravitational environments that shape them. Each data point tightens the story. There's also something humbling in realizing how ordinary these objects may be on a galactic scale. What feels rare to us may be routine to the universe. We have detected only a handful because our instruments are young and limited, not because such travelers are uncommon. As our technology improves, we may discover that interstellar visitors pass through our solar system regularly, unnoticed for millennia. This realization reframes our sense of isolation. We are not sealed off from the rest of the galaxy. We are immersed in it. The boundary between here and out there is far more porous than we once believed. This understanding subtly reshapes our search for life and intelligence. Instead of imagining dramatic encounters, we begin to appreciate slow, quiet processes unfolding over immense timescales. The universe does not hurry. It experiments patiently. Stars are born, planets assemble, materials mix, systems collide, and debris is scattered across space. Out of this vast, indifferent process, complexity emerges. Interstellar objects are witnesses to that process. They remind us that the story of life may be written not in sudden events, but in long chains of cause and effect stretching across billions of years. At the same time, these discoveries force us to confront a very different challenge that has nothing to do with astrophysics and everything to do with humanity's future. We are entering an era in which our tools for manipulating information rival our tools for observing nature. The same ingenuity that allows us to detect faint objects across interstellar distances also allows us to fabricate convincing illusions. This creates a paradox. We are learning more about the universe than ever before, yet risk losing our ability to agree on what is real. The real question, then, is not whether an interstellar object is artificial, but whether we are prepared as a civilization to interpret evidence responsibly. Scientific literacy is no longer optional. It is a survival skill. In a world where images, voices, and authority can be synthesized, the ability to ask, "How do we know this?" becomes as important as the knowledge itself. The future will not be shaped solely by new discoveries, but by how well we understand the process behind those discoveries. Physics offers a model for this discipline. It teaches us to doubt without despair, to question without cynicism. It shows us that uncertainty is not a weakness, but a sign of honesty. When scientists say they are still studying an object, they are not admitting ignorance, they are demonstrating integrity. They are acknowledging the limits of current data while committing to refining their understanding. This attitude stands in sharp contrast to the culture of instant certainty that dominates much of modern discourse. There is a deeper irony here. The universe is more astonishing than any fabricated story we could invent. The fact that matter from another star system can wander into our own, carrying with it the chemical history of a distant sun, is already extraordinary. It challenges our sense of scale, time, and connection. We do not need to embellish it. We need only to understand it. Reality, when viewed through the lens of physics, is endlessly surprising. As we move forward, discoveries like 3I, Atlas will become more common. New telescopes will scan the sky with unprecedented sensitivity. Artificial intelligence will help us sift through mountains of data. But tools alone are not enough. Wisdom must keep pace with capability. The future of exploration depends not just on better instruments, but on a shared commitment to evidence, transparency, and critical thinking. In the end, the universe is offering us a test, not of intelligence, but of maturity. Can we resist the temptation to turn every mystery into a spectacle? Can we allow wonder to coexist with restraint? Can we embrace uncertainty without surrendering to fantasy? These questions will define how we engage with the cosmos in the decades to come. The greatest danger is not that we might misinterpret a passing object in space, but that we might lose our anchor to reality itself. Science is that anchor. It does not promise comfort or drama. It promises coherence. It allows us to build a reliable picture of the universe, piece by piece, grounded in evidence rather than desire. If we can hold on to that discipline, then every interstellar visitor, every strange signal, every unexpected observation becomes an opportunity not for fear or illusion, but for deeper understanding of the remarkable universe we inhabit. As we step back and look at the bigger picture, one truth becomes clear. The universe is not whispering secrets to us through rumors or manufactured voices, but through evidence patiently waiting to be understood. Interstellar objects like 3I, Atlas are not answers in themselves. They are questions posed by nature, inviting us to think deeper about where we come from and how the cosmos works. They remind us that reality is far richer than speculation, and that genuine discovery does not need exaggeration to inspire awe. By trusting the scientific method, by valuing evidence over excitement, and by remaining curious yet disciplined, we honor the very process that has allowed humanity to rise from cave fires to cosmic exploration. The universe is vast, mysterious, and profoundly beautiful, and it reveals its secrets not to those who shout the loudest, but to those who listen carefully. Thank you for spending your time here, for your curiosity, and for your willingness to explore the universe through science rather than illusion. Your attention, your questions, and your critical thinking are what keep real discovery alive. Thank you for watching and for being part of this journey to understand the cosmos.